Welcome to the Poleshift News, the home of the Magnetometer Observatory. Guys, we've had a bit of a build day today. We've managed to build another 2 magnetometers. We're waiting for the CMJ49 chips to arrive. Hopefully, maybe the beginning of next week. I was hoping they'd come today. There is one more post tomorrow, so if it's not in there tomorrow, it'll be in the one Monday. So I've put the videos together showing you how to, how I make these magnetometers from start to finish, and I've also done a bit of work on the cloud generator, which I've also included in the video later on. So if you're interested in those, you want to see how we put the magnetometers together, then stay tuned to this video. The purpose of building the next 2 magnetometers is for M8 and M7, and that's to monitor the South Atlantic anomaly, which is the weakest intensity of magnetism on our planet. I thought it would be a good idea at some point to get these built and put out in those locations, and means we've got some chips arriving shortly. I thought I'd get ahead of the game and just build the magnetometers, and pretty much when the chips arrive, it's 4 spots of solder, click them onto the actual breakout boards that we're programming, and they can go out to their locations. I'm thinking about putting one also, perhaps an M9 in South Africa, because we can see that this low intensity region is creeping up on the south coast of Africa. You can actually see it's not at its strongest, its maximum weakest not temperature. I am shot today, guys, believe me. Been at them wires all day long. I think it's affected my brain, but yeah, it's the actual not the lowest intensity, but we know that intensity is going to be decreasing even more in that region. So I think South Africa would be a good spot to put an M9 as well. If all goes to plan, Scott over in the United States should have 5 of these chips, and if this one that comes Monday is the correct one, then I'll place an order for the rest of them that the guy's got. I think he's got another 5, so if that's the case, we'll put an order in for them, so we've got plenty of backups as well. Should we find another location where we want to place one of these magnetometers, we can. I still haven't heard nothing from Ricky, and I am getting a little bit worried. I'll have to dig out the receipt from the post office to see if it's actually been signed for over in India. So I mean, it could be just the case that he's had it and he's already put it in its place, and he's collecting data already. But it'd be nice to just get some acknowledgement that it has arrived safely in India, and that is the case. So guys, big thanks to those people that are supporting the work that we do on the observatory. We're always spending money these days on bits and bobs. When you think about it, you can't just buy one pack of one resistor. You have to buy a whole packet, and it's pretty much the same with all electronics. You can't just buy a little piece of heat shrink. You have to buy a whole package of it. So we're always spending money here at the observatory, and it is great when people support it, because it keeps us stocked more than anything, and it helps us get these out to the locations where they've got to go. So if you want to put a bit of support in, you can do that on Patreon, or you can just make a one-off PayPal donation if you want to. But the important thing is that we keep the observatory funded. That's the be-all and end-all, really, guys. Anyhow, let's get these videos rolling, and you can see what we've been up to today at the observatory. Mavstar Cave, and trust me, we really need to be thinking about building a workshop at some point to put some of this stuff in, because it's just one of these days I'm going to walk in here, I'm just going to get crushed to death by an avalanche of just things everywhere. But what we've got to do today, a couple of things I want to get done. I just want to make up these leads for the jumpers, because I've had these for nearly a year now, and they're really handy if you just want to join 2 wires together very quickly. Just give you a quick look at what they are. They're just jumpers, nothing flash, but like I say, very handy. So I'm going to solder up a couple of those. We're going to build a couple of magnetometers, because hopefully we've located now some of the CJM49 chips, so we can get a couple more of these built. We've got plenty of cases and breakout boards to do that, and then we're going to put all these peltier elements together. But before we do that, we're going to solder these 2 water blocks together, because we're going for now the liquid cooled cloud generator. So guys, I'll show you a couple of videos getting through some of these things, and you know, we'll see how we get on, see how much we can get done. Get those finished. As you can see, they're all done. They're just good for joining a couple of wires together if you need to just test something. You know, they clamp each other on little hooks that come down when you press them. But I've got to say, you know guys, you know, it took about 20 minutes just to solder just 2 wires and 2 terminals on these things. You know, some jobs take longer than what you actually think. Anyhow, let's get on with what we've got to do. So we want 2 magnetometer boards or boxes. We need a couple of breakout boards or Arduinos, some batteries, and a couple of shields. And what we're going to do is, if I just move these out of the way, I'll just show you what we start off with is an Arduino Uno. That's our computer breakout board. This is what we program to tell, you know, that it's got a magnetometer attached to it. And then we put a shield to it, which looks like that. And that's so that we can record the data onto the SD cards. And then we've got to solder up some wires on here and fit a couple of batteries onto these, which are here. So a battery goes in there for the clock, and it just keeps, you know, the time for us on the actual Arduino, because we're taking date time readings. That's where that fits in there. And there's a bit of soldering to do, so I'll get on with the soldering and then I'll show you where we are with that. What we'll try and do is we'll try and get another 2 of these built, even though we're still waiting for the CJM49 chips, and I'll show you one of those when I undo this one here. So give me a few minutes and I'll be back. Show you what we're going to do. As you can see, we've got one already completed there. You can see that the magnetometer is just on the end there, in the end, at the front of the box. There's 4 wires that come off that to go to the analog pins on the breakout board, to go to the 3 volts and the ground, and then we've got another wire just here, this black one, coming off the LED to the ground, and then another one coming off there, the ground. Because the good thing about these boards is there's plenty of places to take lives and earths off, but you want to get the right ones. Obviously, when you've programmed this board, you know, say on pin 10 there's an LED that will flash once. You have to tell it how bright you want it to flash as well, or for how many milliseconds that you want it on will determine how bright that LED is. And we've also got one here on pin 2, and again it's programmed on the board where all these pins go. And that's what we're going to do now with these. We're going to solder these wires onto these various pins and outputs. Before we do that, we've got to build a couple of LEDs, and we've got to put a resistor on the LED. You can just see that there. And then we're going to shrink wrap all these after we've done it, so that they don't come into contact with other components on the board and short out the board or the LED, in turn blowing it. So that's what we're going to do. So we've got some wires. These are what the magnetometer are going to clip to. Because we're building 2 of these magnetometers, we're just going to quickly snip them in half like that, and 2 of those will serve that magnetometer and 2 of them will be for that one. So let's get some wires soldered up and we'll show you where we are then. So we've got the rework soldering iron here, but it also comes in handy for doing little jobs like this, just reducing that shrink wrap on the LEDs. It just protects them when they're in the magnetometer case from colliding with anything else. And all this we're doing is just applying a bit of heat to the shrink wrap and just making sure that we've covered, you know, all the ends of the wires so that they don't come into contact with anything else. So when we start off, we just slide the stuff over the ends of the wires, and then, you know, very easily, as you can see, apply a bit of heat and it just shrinks them over nice and neat and tidy. and the last one. Having the right tools does make a big difference, you know. It makes things a lot smoother, a lot faster. I mean, the ideal purpose for this rework soldering iron, it's a hot air device, just blows hot air. You can set the temperature on the station up there. I've got it set for 289, something like that. But the nice thing about it is, if you've got to remove something with lots of soldered connections, like EPROMs and things like that, this will do it very efficiently for you, as opposed to heating up one and then getting the tweezers and remove it. If you see on these these chips here on the board, where they've got lots of soldered pins all the way around, well, the good thing about these rework guns or hot air soldering irons is they can heat it all up without damaging the actual chip. And you can set the temperature as well with these guns, so it's brilliant for that. I mean, as opposed to, you know, just going at it with a soldering iron, you know, one pin at a time. It'd be very tedious, take a long time. But before these guns come out, that was the only way to do it. So there we go, I'm happy with that. Let's get them soldered to the board. As you can see, all the wires are now soldered onto the actual breakout board. What we've got to do next is complete the boxes, and that just means you've got to drill a couple of holes for the LEDs to go in, you know, another hole for the reset button, or the peg that we use. In this case, one of these, you know, we just leave a little hole there so that every time the SD card's put into place, we can just quickly reset it with the peg and remove it so it's not accidentally knocked. And then we've got to cut out a little section of the boxes so we can install and remove the SD cards as and when we need to. And that is pretty much it. Most of the hard work's done, so we'll get on with you know, drilling the holes and cutting the backs out the boxes, and then we can hot glue gun the actual electronics into place and put the LEDs where they need to go on the top of the magnetometer, and then those are finished, and then we can move on to the cloud generator. We've completed the magnetometers. LEDs are back in the original positions, been glued in there. You can see in there the SD card and the breakout board. The only thing that these have got to have before they go out is the magnetometer chips, and they just click on the front of the boards that we've put there now. The little wire pack is glued on to the board at the front, and that's it, guys. That's another 2 magnetometers that can go out perhaps in M7 and M8 to observe that region of our planet where the magnetosphere's at its weakest. It's commonly known as the South Atlantic anomaly. That's the area that we will probably try and get these ones out. This one's going back to Richard on the Gold Coast. Monday we'll get that in the post to him. It's got a new SD card. The program's been put back on it correctly. And the only other thing that these have got to have, other than the magnetometer chips, is the programs put back on. So if you remember, we load up the RTC, the real-time clock, first of all, to let it know it's got an onboard clock, and then we put the program in there that tells it's got an SD card writer and also a magnetometer in there, and it also, the program also puts the data in a specific way in which we can easily process it. And one way we do that is by separating each piece of data, like the time, the date, the month, the year, with commas, and obviously which magnetometer took the reading and what the magnetometer UT strength was at that time. All these bits of information separated by commas, and that's how we're able to process the data into charts very easily. So I think what we'll do now is we'll put these magnetometers out of the way, and we'll do a little bit of work on the cloud chamber. Now I'm going to solder these two cooling blocks. As you can see, they've got inlets and outlets on them there, and there's two of them. We're going to solder them together with the blowtorch, this thing, and then we're going to put the array of Peltier elements, these things, on them as well. I might use the thermal paste just for now, just to sit them in the positions where they've got to go. So we'll get some thermal paste on there, and you know, we'll do that. I'm still waiting for the fans and the radiator to come for this, but we can tidy up all the wiring and get the actual heat blocks in place where they need to be. And when the fans come, obviously then the only thing I've got to order, might do it this evening, which is a water pump to cycle the water around constantly, and some flexi hose to go on these outlet tubes there. And we'll see. I'm hoping that this is going to be it, guys. You know, this is going to get us to those sub-zero temperatures so that we get good visualization of the cosmic particles. That's what all this is about. It's about looking at the cosmic particles and seeing whether there is a considerable increase over time. So, you know, we can take like over an hour, we can see how many particles passed through the cloud chamber, and then perhaps in 6 months' time we can do the same again over an hour's time, see how many particles go through there. I'm just wondering if I can rig up a light photo sensor to pick up the disturbance through the alcohol vapour in the bottom of this cloud chamber, and, you know, let the machine count it itself. I don't think it would be very difficult to do that, and to you know, write a program for one of these breakout boards that could monitor just the amount of cosmic strikes we actually get through, coming through the chamber itself. But there you go, let's get on with it. We've managed to put the blocks together and set the Peltiers now with the thermal paste on the water blocks. We've just trimmed up the wires neat, because these have all got to be joined up now, and that'll be a job for tomorrow. I think we'll just leave the blocks to set together nice and firm, and then we'll pick it up from there tomorrow. But you know, it's coming on. Maybe tomorrow we'll connect them all up and we'll do a test just to see what sort of temperatures we get without the water flowing through the block, and you know, we'll look at how we're going to fix it to the actual base as well. So, not a bad day, guys. We've managed to build another couple of magnetometers. We've made a good start and some progress on the cloud generator, and you know, like I say, I've been at it all day, so I'm going to call it a day, and join me tomorrow. So there you go, guys. Like I've said before, you know, we're proactive at this observatory. You know, we're international. We've got magnetometers all around the world, and hopefully we'll have M8, M7 in the not too distant future, and we'll have our up and running cloud generator. So, you know, I'll just leave it with what I usually say, guys. You know, there are links down there if you want to support us. There's a lot worse things, trust me, you could do with your money than support an observatory. You know, and some real scientific research that's taking place. You know, again, we're not funded by corporations, and most of you already know why that is. I say it every time. It's crowdfunded. It's generated by you guys, and it's dedicated for you guys as well. So the links are down there if you want to support us. I'll say what I usually do. Catch up with me tomorrow, and we'll see how much more we can get done on that cloud generator. As always, bye for now.